Oh, hello. Quick audio check for the stream, but also a good reminder for the people here that we start in a minute. So please take your seat. We try to be on point. Yeah, good evening or good morning or happy lunch, everyone here. Welcome to this. Moving further. Yeah. Uh, First slide and already incorrect. It's not only the .NET Community Austria March 2024 meetup. It's also the, how do you name your meetups?
Unity Meetup Vienna.
March or first in 2024?
Yeah, let's say March.
March. Okay, good. Yeah, special meetup today. We're doing this together and took us some time, I think 6 months. But finally,
we are here.
Yes, we are here. Yeah, .NET Devs. So the .NET Community Austria Meetup is organized by a non-profit organization called .NET Devs AT. You can find us everywhere, and it's still Twitter. Yeah, thank you all for joining here and on stream. Stupid focus. Yeah.
Thanks to our sponsors, Svarmony, our long-term sponsor, and Greentube. Thanks for making this happen here at your home base. Thank you very much.
Yeah, thank you. Okay, forget the clicker. Thank you also our sponsors, Tieto Every and Rubicon, who sponsors us. So .NET SRT financially, that we can have the streaming equipment and everything, and also that we can fly in speakers next month. We will do this the first time. And also thanks to JetBrains, they are sponsoring a 12 months product license, and we will do this as a raffle. And how do you take part in the raffle? You have to type in JetBrains in the chat, and the raffle is already running for the long-term visitors. Not forgetting this mix. So you can also join here in the chat, and then we draw it after the talks live.
The chat on Twitch.
Yeah, Twitch or YouTube. Good. And with that, some quick community news. There are some events in the coming weeks from friends of us. First, the Coda Dojo Wien. It's the next events are in March, end of March, and April 12th. Then there's the Como Camp in May, and also the Codecraft Conference, also middle of May. The .NET meetups, the next one. So the next one is on April 16th. It's by Bas Dijkstra. It's about solving the integration testing puzzle with contract-based testing. Happens as Rubicon. Bas is a expert in test automation. So looking forward to that. And thanks to our sponsors, we can fly him in. And in May 28th, Raul Holzer and David Ivan will talk about their experience with WinUI 3, the App SDK, and RX.NET. And this will happen at Tech Talk. And
yeah, we have the next Unity meetup at April 30. We will announce it soon in our meetup group as well. You can bring some slides for a short lightning talk. Very little preparation effort. Come and join us. We might go to do it more regularly. So we have the idea of doing it every last Tuesday of the month. Let's see. Let's do the first one to try it and see where we go from there.
Cool. And I think with that, special thing. We had only one topic on the first, but today we have two talks. The first one by where is it there? Daniel, about using Unity licensing. We thought .NET, there was some explosion about licensing. So to get a catch up also for the mainly for the .NET people that not that in Unity, and afterwards we have then the main talk. And with that, we quickly switch equipment. So give us a moment. Your stage.
Okay, so hello everybody. My name is Daniel Conde Linares. I am the head of Unity development in Svarmony. And I want to talk to you guys a bit. I mean, they asked me to have a lightning talk, so I will try to make it as smooth and easy as possible. But it's all about the. Is it okay, the sound?
Test. So that microphone is working. Okay. So, but why do we have a passing on
the... Go over there. Okay, so let's. Okay, so I first will talk super quickly a little bit about Svarmony. We are a XR company with more than 15 years experience in developing XR products, and we have work with different clients from Porsche. We make the Porsche visualizer. We also work with Audi, a lot of automotive companies, also home appliance companies, or a lot of different challenges. We also work with a lot of different ecosystems that supported also in Unity, like native libraries for AR and different SDKs, third party like Buforia. Wiki2 doesn't exist anymore, Visual Leaf, and so on. And we have three main solutions that work with each other. One is RI for inside navigation, another one is Avatar, and another one is a visualizer and configurator of products, and they exchange with each other. And also we are hiring if somebody is interested. So what happened with the Unity license? So there was a big storm happening around when it was the 12th of September, when Unity was announcing unilaterally the change of terms of service to add a runtime fee. This was, of course, a big hit for everybody, mainly because the way they did it was with retroactively. So all the games or all the products ever made with any Unity will be subject to this runtime fee. And that was, of course, like causing a big chaos everywhere, no? Because it just make everything unpredictable. No? This runtime fee was based on installs of applications with a kind of like not clear way of how this install will be accounted. So of course this wasn't not acceptable. And the other problem was that the situation was a bit getting worse because man, sorry, I'm a bit nervous. Because this thing was kind of like prepared. Somehow Unity was changing the term of service under the hood before actually making the announcement. There was one clause that was actually added around 2019 to state that Unity will not be changing the terms of services for current versions. So if you use a specific version of Unity, you will always be bound to that specific terms of service that this Unity version was having. And this they changed in the night, and then they add this runtime fee. So it was like, but this was little by little discovered by the community in a rage kind of movement, like why this is happening. Why suddenly we have discovered that the CEO of the company has just dropped some shares right before making the announcement and all this stuff. No? So it was a bit shady. The sequence of events in kind of like in a timeline was first it was the announcement, then there was the public statement from studios all over the world saying this is not okay, and we will not be using Unity anymore if this is staying as it is. No, like I don't know if you guys know, for example, Cult of the Lamb or some other games that were saying, from the 1st of January, we will not have the game available anymore, so just buy it as soon as you can. Then 15th of September, there was an all-in meeting plan in the Unity headquarters that was canceled because there was death threats. Actually, that was coming from inside of Unity, from a Unity employee. Unity's employees in general were really pushing to revert this whole situation because it was also affecting them. They care about the engine. And always this engine that has been promoted as a kind of like democratizing game development was just stabbing everybody's in the back. No? So then in September 17, there was formed a little coalition of game developers. Everybody was having analytics or Unity ads were turning them off until the situation was resolved. So, in a kind of like, if you want them to listen to you, you need to hit them in the pockets, no, in the wallet. Then September 19, it was also launched the project Uni3. That was basically a tool made with ChatGPT and other open source tools to transform Unity projects into Godot or Unreal, or actually Cocos Creator. And yeah, I don't know what is this project at the moment, but there were so many different things going on at that time. Like you could see a swarm of tutorials of how to switch from Unity to Godot, pages rambling all over. This is exactly what you need to do to switch your game, what is running. Don't ever start with Unity, blah, 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 blah. So it was a big haptic, this whole thing. No? And then in September 22, that was basically 1 week, well, 10 days after, finally we got some open letter from Unity where they were basically saying sorry and saying that they're gonna revert most of the stuff that it was the most conflicting. We still have a runtime fee. We will see in the next slide that is not really affecting most of the game developers, and actually compared with others game engines is kind of like the same average, no? But something that the community wanted was transparency was finally somewhere there. If they would have told us from the beginning, hey, you know, we have economical problems, we want the things to go on, we just need to change the pricing or whatever, everybody would have understood more or less, you know, we have to adjust our budgets. But doing the things they did, that was what was not okay, you know. And then as a, you know, as an extra note, in October 9th, the Unity CEO was leaving the company. So that was a big hooray for everybody. And as a final statement, which is basically the new Unity license, you can access actually all the license information if you get the QR code from Chrome. The new changes are in Unity. We used to have 4 licenses. So it was Unity Free, Unity Plus, Unity Pro, and Unity Enterprise. Now there is only 3, Unity Personal or Unity Free, Unity Pro, and Unity Enterprise. With Unity Free or Personal, you have a cap of, you are able to use it as long as you're not making more than $100,000 in the last 12 months. So that is going to be increased to $200,000, and you will not be forced to use the Made with Unity Splash, which is also nice. And it will never be subjected to the runtime fee. Then the only other licenses that are subjected to the fee are the Pro and the Enterprise. The games that are made now with the versions of Unity will not be affected with the runtime fee. This is the other major claim from the community, not retroactively appliance of the company, also of the license, sorry. So it will only be subjected to the new versions of Unity, and they again restore the term of service and the clause that everybody wanted, that was term of services will be bound to Unity versions. So runtime fee only enters with the upcoming Unity 6. What else? There are 2 major thresholds when a Unity fee, even if you're using Pro or Enterprise, are being applied. First, you need to make more than $1 million per year. And the other is you need to have 1 million installs. And these 2 elements are self-reported. That is also one of the major gains from the community. This is no shady analytics anymore, which is calculating your installs. It's just self-reported. Actually, Unreal, I think it has the same model. And the last topic is once you cross the threshold, so if you need to pay the fee, then you either have to pay a 2.5% of your monthly gross revenue, or pay monthly, so a fee based on install monthly. Whichever is lower, as I told, is self-reported. that's basically it. That was the final step on the whole runtime fee battle and story, and how it is at the moment. That's it. So thanks a lot. But I don't know if there are questions or something. Uh-huh. Uh-huh.
Stop. Now, please.
Yeah, okay. We had a talk with Unity last week, and they doubled down on that, explaining what you just said. But also, you know, there's the Pro support is 2 years for every Unity LTS. The Enterprise support is 3 years for every LTS. Unity 6 is actually 2023.4, if I remember correctly. Yeah. So meaning if you want to have support for your Unity project and you are currently on 22, you have time till 25. And then if you want to have continuous support, you probably have to switch to Unity 6 at that point. So you're not completely free to choose when to switch. There might be some things that force your hand.
When you have Pro, you have when you have less than Enterprise. If you want to be sticking with the latest non fee base, then you can be until 2025 with the Pro, 2026 with the Enterprise.
25 with Enterprise.
So 25 Enterprise, 24.
So end of 25, and then we'll probably something like
yes. So 25 with the Pro, 26 with the Enterprise. I burn my hand.
Good. Any questions from here, from the chat? No. Then thank you. Thank you. And quickly technical intermission for the next speakers. You need to stop sharing. We don't. He's the producer.
Audio check. Test. Good. All right. Do you want to introduce talk?
So that was sharing. Please screen share.
Yeah. Alex.
Yeah, please. Yeah. Screen. So then when you want to show something else, you need to. You only share the screen, not only the window, not the whole screen.
Yes, I will have to pass.
Exactly what you see now. So if you want to show us that, you need to change.
Then I will share the entire screen here. It's better.
Yes. So, good. So we are getting quicker and quicker. So now to the main talk of today, and Alex and Peter are showing us how to build a 1v1 game based on, I think, SignalR.
SignalR, .NET, Unity, everything.
Everything. So your stage.
All right, thank you everybody. Thanks for coming this evening. So we have a game that me and Peter built as a proof of concept. We wanted to try out some new technologies, both in the front end and in the back end. And we're gonna use some distributed systems. Of course, this is a game, but if some of you are not developing games, this might be relevant because you will see at some point in the backend part, we have some distributed database with Cassandra, and these kind of things might be relevant for everybody. So let's start with the agenda. So we will introduce a bit more who we are and the building that you're here, Greentube Funstage. We're gonna go to the functional and non-functional requirements that we set for this proof of concept, why we picked Naval Battle, a little bit of architecture overview, and then we're gonna dive into front-end and back-end a little bit more into detail. And we have a demo, so the game is ready to be played, and we will show to you how we want to play. And at the end, we have Q&A and questions if you have any. But if you don't understand something, please interrupt us whenever you want. All right. So me and Peter. Peter, please go first.
Okay, yeah, hello, I'm Peter. Yeah, I'm basically part of the Viennese game development scene since roughly '93 when we released the first game back at Neo Software. I don't know if somebody knows about that. Probably only those guys who are interested in game history. So I don't know. And since then, been here in Vienna making games mostly, and then later on switched to apps. And I'm here at Greentube, Funstage, making casino apps mostly. Yeah, well, I love playing games, and I love making games. And I wanted to actually have the first game played after you mentioned your first game played, because that now is kind of not funny if it does first.
Yeah,
you messed up my game. Anyway, so yeah, apart from programming, I like to make music, and that's basically it.
Right, so you probably read everything here. Highlight 2 cats and 1 dog. No, it's okay. So first game I played is Hexen. Hexen was developed in 97 or 98. I recently discovered that it introduced one of the features where the trees would rotate towards the player. So you would always have a feeling of 3D, even if it will be like a flat image of a tree. So this is quite nice because the first game I played introduced like a big change in the 2D, 3D games back then. And yeah, I also love playing games, making games. We're actually working together, and I'm in the backend part. Good. So we're here in Greentube House, home of games. So Greentube is quite old company in Vienna, has been founded in 2000, has released quite a few famous games. I think the most famous one is Ski Challenge. It's still active. You can play it on mobile. And it's actually famous outside of Austria as well. But Greentube as well has 28 subsidiaries in 17 countries. We are more than 1,000 employees, and we have several hundred millions of players all now spread across our platforms. So our main topic is load and heavy load of our players. Funstage is a subsidiary of Greentube since 2004. We're focusing on social casinos, and in particular, the most famous ones are Game Plus Casino and Boom Boom Casino. Now we have the functional requirements. So we wanted to show to you why we went with this proof of concept. So first, the main requirement from the business is spectate and replay the battles. So in Naval Battle, you play 1v1, but we wanted to have the possibility of sort of recording the battles and being able to view them afterwards, or view live battles of other people battling. So the technology, like the methodology that we decided to go for is event sourcing for recording the game actions, so they could be replayed afterwards. And in particular, each move of the players will be a single entry in our database. We wanted to use a database that would scale with almost unlimited load. So we went with Cassandra because we have experience with this. It's very convenient. And Cassandra is managed by DataStax Asta if you want to have a managed service, and DataStax Asta has Asta CDC, which is a capture tool that enables you to forward all the events from your database. As soon as the row is inserted into the database, it's broadcasted to a messaging system. So you can do stuff with it afterwards. We will describe what happens actually in the game. We wanted to have a way to make sure that crashes will not prevent the battles to be continued. So the players will not lose progress while a crash happens, because we know whatever you do in the backend, in cloud, especially if you're hosting, there will be some innocent Azure update. They just do OS updates and they just restart your servers. So you can control this a little bit, but automatically they do it anyways at some point. So we wanted to ensure that this will not break the gameplay. And we need to have a way to reconstruct the state of the battle after the backend restarts. From the front-end point of view, we want to make sure that if the player puts the app in the background and restarts the app, he can go back into the previous battle that he didn't finish. So we need some backend logic to handle this functionality. I will go more into detail later. And the front end will have a persistent client state. Another important requirement is unified web and mobile development and gameplay, because Funstage has a good experience with browser games. So we mostly, we have 50% of our players from mobile, 50% from browsers. So we want to provide a proof of concept that would still support all of these players. So we need technologies that support both, basically. And also, ideally, they should be able to play against each other, because in this case, Naval Battle is a simple game. There is no reason why they should not play web against mobile app and vice versa. So the go-to technology that we found is WebSockets. This is well supported across major browsers, and in particular SignalR, because this library is native to .NET and also has clients for JavaScript and Unity3D. So we had always easy time with SignalR in the past. Then we said we want to scale this game, and it might be the case that we want to deploy some instances into multiple regions like Europe, America, Asia. So we want to do this in a very easy way, and we need to have it monitored and controlled and managed centrally. How? Well, we have experience with .NET and we have experience with Azure. So for us, we just said, let's continue going with containers in Azure. And from the database point of view, DataStax, so Cassandra, managed Cassandra, is already providing multi-region distributed database. So we don't have to operate Cassandra, which might be quite complex at a global scale. We're also going to use OpenTelemetry, Prometheus, and Grafana to monitor what is happening in our backend. Then ETL and data processing. Some of you might not be familiar with ETL. It means extract, transform, and load. This is the process where basically you give all of your backend data from your main database to other teams in your company. They run analytics, they run marketing on top of this data. They try to segment the players, try to figure out what is happening on your platform, try to improve it. So for us, this is a common process. And we need to ensure that this still happens smoothly. And we want to create afterwards dashboards and views for analytic purposes of how many battles are happening, which countries are more have the biggest load, and so on. So how? Again, DataStax Asta CDC change data capture has native support for sending data to Snowflake. So I explained briefly earlier that when you save insert a new row in the database in Cassandra, DataStax Asta CDC triggers a message into messaging system, and you can connect this to your data lake, for example, Snowflake, and you will have automatically all your data in Snowflake. The last requirement is 3D visuals. So we want to like give to the players the nicest experience possible with 3D graphics, so as fancy as possible. And basically, we noticed that the players are way more engaged if you go with native 3D graphics. And here I can open a parenthesis. We recently released Boom Boom Casino, and this is our first game made with Unity by our front-end team. And it actually got way more traction, and players are way more engaged with this platform. It's very nice. It has like the whole garden feature where you plant your flowers, you collect the bonuses, and just because it's so nice and 3D rich, the players are way more engaged and they love to stay more on this platform compared to web platforms, for example. So the go-to technology was Unity 3D because Unity 3D it's a very good tool for the deploying on Android and iOS. And if one day we want to deploy on other platforms, we can also do that. Then some extras are non-functional requirements. So other than what we need to achieve for the business, we want to have some additional requirements. For example, we have to easily scale. So in the past, we used to run everything on premise in our data center here in this building, actually. We have very powerful servers, but they will not scale, and you will not have the possibility to deploy globally. So we want to go on cloud, and we want to go it in a way that we still control the costs, because on premise, you control the cost because if you buy a machine, you know how that machine costs, but on cloud, you have more issues and you might forget about a very powerful machine running on, and the next day you have a huge bill. So everything has to stay under control. And we also want to plan and budget this. From our experience, using reserved instances on Azure is the best way, but in order to reserve instances, because you have to reserve them for 1 year or 3 years, you need to know how much you need to budget. So we need to have a way to really monitor the resource utilization in order to achieve this. We have experience with Azure AKS Kubernetes. This is a nice tool that is managed by Azure, and you just create your container of your application, you deploy it on AKS. You can manage multiple instances, you can manage networking, but in this case, maybe it's an overkill for the naval battle game, but if you plan to have a bigger game like that has more complex backend logic, then AKS is a good tool. Otherwise, I would recommend to go to some managed container services from Azure or something smaller. And OpenCost is an open source tool to manage the cost. In AKS, it's installed on any Kubernetes cluster, you can install it. And if you give the correct information about your cluster, it can tell you in real time what services are costing what. So this is a very nice tool. Prometheus and Grafana, for who doesn't know, those are some very common tool to monitor your services. So Prometheus is sort of like a database aggregator of all of these metrics, and Grafana is like a tool where you build dashboards on top of these metrics. So you collect the metrics from all of your instances, and with Grafana you can visualize, so you can see how much you're spending or other stats about resources. Before someone asked, why didn't we use serverless functions? We thought about it. From our experience, serverless functions are a good way to go if you know that you're going to stay small from the beginning to the end. In this case, yes, naval battle for us was just a proof of concept, but what we built in reality is more complex. So with serverless functions, you end up having actually dividing your code in too many smaller functions, and when you have hundreds of them, it becomes like a bit hard to manage. So yes, just as a recommendation, you can start with serverless only if you plan to stay small. The last requirement is something that we also gain over the years as experience, the real-time performance. So we introduced real-time features on GameTwist some years ago, our main platform. And we noticed that the players are way more engaged. Real-time means I do something, I immediately receive a result of what I'm doing. And I can interact with other players in real time. This is something that makes the player way more engaged to your platform. So what does it mean, real-time performance? Obviously, fast and smooth gameplay for everybody, but we don't want to have loading screens or loading icons. Everything has to run as fast as possible. And in particular, we noticed that the hot point where you want to be is below 150 milliseconds. So possibly all of the requests should happen within 150 milliseconds. We did some benchmarks, some A/B testing, and we noticed that above 150 milliseconds, the players stop interacting with your platform. On a larger scale, you will see degradation of the user interaction above 150 milliseconds. Now, how actually build performant backend that can scale under the load? So of course, and use semi-stateless backend instances to avoid loading the state from the database. So this is important because also from the past experience, it's very hard to provide real-time performance at a very large scale. So we're talking about 50,000 concurrent requests per second. We had this kind of load in during peak times. You cannot really go to the database. You need to have stuff running in memory or in cache or in Redis. Even Redis, it's maybe a bit too slow sometimes in very particular cases. So for us, the solution was to have the state in memory. And of course, in this case, it's a distributed backend, so you need to have the battles in sync, because if for any reason your player disconnects and reconnects to another instance, he should not start from scratch. He has to go back into the battle as he was before. All right, so why we choose Naval Battle? So we discussed about a couple of games. We had chess, we had, I don't remember, some other prototypes. Tic-tac-toe, yeah. And we decided to use Naval Battle. Why? So because it's very famous, everyone knows Naval Battle, and there is no complex business logic to be built. So for us, we wanted to try out some technologies. We didn't want to ship this game to the stores. So we just wanted to achieve our goal as soon as possible. And also, because it's turn-based, it saves us a lot of headache. So you will see at some point, I will talk about cheating, but turn-based makes your backend life way more like chill, because you don't have to handle concurrent players doing actions at the same time and trying to having rules where someone has some priority or someone must not do something at the same time as some other players. We don't, and also matchmaking. For who made matchmaking in the backend, this is not a simple task. You have matchmaking based, like putting together the players into the same battle based by the region, by ping, by level. So in this case, in Naval Battle, it's just as soon as you have two players trying to start a battle, they will join the same battle. And Naval Battle is asynchronous in the sense that I can send the actions that I want to do in the game, and eventually I will receive the state. It's not a first-person shooter, so I don't need to sort of predict what is the backend going to tell me. So I have to make like this kind of projection of the movement. It's very simple. And frontend can make an action, can make a request, and eventually the backend can respond given the latency. So what is the logic that we're gonna show to you today? We're gonna have a very small matchmaking logic. We're gonna have the joining of the battle when two players are ready. They will place the ships, and they will have 3 available ships. This is configurable. When they are done, they can say they are ready. and we will show you how hitting a position actually works in the backend. So you have to hit the opponent like board in a specific coordinate. And of course, when all the ships from the enemy are destroyed, you win. So now we have the architecture overview. This is really an overview. It's I wanted to make it as simple as possible, just for you to have a quick picture of all of the parts that are like moving that you will see today. So this is our player. He has a mobile application. He connects to our .NET backend using SignalR, and he joins the matchmaking. A second player joins the matchmaking, and then the battle is created, and the backend starts pushing this information to our Cassandra database. The actions, so for example, place a ship or like hit location, they are all stored to Cassandra. Cassandra automatically sends data via Astar CDC to this messaging system. In this case, the messaging system that DataStax Astar uses is Pulsar. Pulsar is similar to Kafka or RabbitMQ. It's similar. It does a very similar job. And we can listen to these messages in the backend backwards, and we can change the state basically of the battle in memory, and then we can give the result back to the UI that will show, like Peter will show how this actually works. The UI is reactive. So as soon as the front-end application, the Unity application receives the data, it will reactively change the information on the screen on the button. Good, I think now it's your turn, Peter.
All right. Okay, first off, I didn't get the memo about the highly sophisticated 3D visuals. Everything is code art, so please keep that in mind when you see a demo afterwards. For Bloom Casino and for the other apps, we have Game Twist and so on. We usually have this kind of snapshot and update approach. So we would initially get the state of the application via REST API calls, GraphQL API calls, whatever. And then from that on, we would update our data models with some messages that are sent by the through server. And the snapshot will be fetched at application start or application resume, and the application is coming back from the background. And some other neuralgic spots, we would do that. But for that demo, we just said, okay, forget about the whole snapshot fetching. There's an API call. It's just everything is done via messages, which okay, now, do you hear me? Is there only the choice to either breathe or talk? So handling everything through messages is kind of annoying, to be honest. It's because usually when you do API calls, you can say, I wait my response from my API call, and the response I get is actually what the API call was doing. That's not the case for the messages. So let's give a quick overview of what is actually happening. So when we invoke a command, the response we get is not the answer, or it's not the response of the API call. It's actually a technical response, just saying, yes, we received your command. Yes, we could deserialize your request. Yes, we didn't fuck up the request, but there's no response whatsoever. It's awaitable for us. We cannot await sending the response and continue our flow by just awaiting an API request. That's not happening. Instead, at some later point, as you mentioned, 150 milliseconds later, we will get a response with the actual answer. But at that point in the front end, we are somewhere. We are not there where we were before, because there is no awaitable sequence. And for me, this POC was kind of a possibility to try out how we could get around that. So basically I would call it async squared, because it's usually async is you can await some async call, but in this case you cannot await anything. It's just a callback later. Super annoying. So it is. You know what I'm talking about. So just as a quick overview, first, when we get a message from the server, we do not really have every part of the code react to that message. Could, but we don't want to couple too tightly with the data structures from the backend. So usually we have message translation ongoing, and we would either directly at a central place receive the message, put it in our data model, or convert it into other kind of local messages that have our data type, and we send it along in the local message bus. So how would sending a message roughly work? This is one possible approach. So basically, we could say, yeah, we define for every message that we pass a kind of key that is the essence of this message. Like, for instance, when we say we want to hit a position on the battlefield, the key could be a tuple of the message type, which is hit position, and the play ID. And we register, let's say, a response callback for when a later point the messages arrive. We can then execute this, and then that leads us to the third thing that we could do when we receive messages, which is invoking the pending callback. So we receive this message from the server, and we can directly defer from that. Yeah, that's the type hit position for the play ID, and then we can say trigger whatever you have registered there, which would allow us to define, at least locally, very closely to the sending the response, what you should do back then. But still, it feels kind of 2010 programming, having callbacks. It's not what we would do nowadays. But since you can define a callback, right? It doesn't. If you can do whatever you want in a callback, you don't have to do the actual code you want to do. If you receive the message, you can just wrap the whole thing in task completion sources. I don't know who used that in their code. You can basically create your own async function doing that. So you can define a task completion source, and you just set that to the result when you receive the message. And this enables you to do something like this. You can just say, I await my sending the command, and then when later the message arrives, this await will be fulfilled. So it feels almost like an API code. You just have to specify this key, which you would not normally not do, because there's still this code in place which actually resolves this callback, which defines the await resolving. So that's nice, because that feels again like an API call, although it isn't. There might be, I'm not saying seconds, milliseconds between the calls. So but it's an improvement. Which leads me to the next thing, because that is only the case for when I'm using messages as an API call replacement. So I request something and then expect a response. Very often, we just get messages at any other point and we have to react to them. And that leads to that topic, which is concurrency might be hard, especially if you update data models from different threads, right? You don't want to have somebody update your data model while you actually in the process of processing it. You want to update a view while somebody is updating your list of elements. That is usually just a situation where everything gets bad. So either in the best case, you just have an artifact in the view because elements are there multiple times, or you get exceptions because you process a list while somebody else is modifying it. So there's a couple of approaches usually to get around it. First one would be locking. Sorry. So everybody knows that. So you can lock access to the data for a specific code block. When you say I'm entering a lock for that data type, nobody else can write that data, modify the data, or read the data. I don't like locking because it forces you to think about how to lock when you write and when you read data, and that is something I really do not like. It should be enough to just thinking about the hard parts when you write data, but not when you read data. It might be okay if you just read data of plain types like floats, int, whatever. But as soon as you read containers, you still have to lock that stuff. Otherwise, it might happen that somebody else writes something while you're operating on it. So I don't like locks. and also there's whole chapters in the design patterns on how to properly do that. Keep the log code small, don't call external functions. A lot of rules, and you have to think about it all the time. That's annoying. So what we went instead for is immutable state, which is another possible solution to get around the current currency problems. What does it mean? So we have internal data models, and there's an internal state for every model. And you can, if you change something, you have to change that state, but you cannot just modify the existing state of a model. Instead, when you change something, you have to create a clone of the current state, copy all the data to a new instance of that state, and just change this one data entry you want to change. And everybody else who had a reference to the previous version of the state is safe. Nothing can happen to them. They are perfectly safe to process lists, whatever they want. Nobody can operate, nobody can change their state. And then afterwards, when they're done, because they're operating on old data, basically, they might get a new version of the state pushed, and they can, again, update the views with this new state. That, again, is not trivial, because because writing of the state or mutating the state is very depending on what kind of data you are actually changing. If you just have, let's say, some bools or int values in your state, then that's a no-brainer, right? You can just create a clone of the previous state, change the values, and that's it. But if you have some hierarchy, some deep hierarchy, nested hierarchy of lists of dictionaries with objects, and then again lists, you have to be very careful on what you do. So if you have, let's say, a list of dictionaries, and in one leaf of the dictionary you want to change some data, you have to create a clone of that dictionary, change the entry, go the way up, create a clone of that list for this one entry, replace the entry pointing to a new dictionary, and on the way up you have to clone every part that you touch, basically, to make sure that everybody who has a reference to some part of the data will not be affected if you change something in that data. Well, there is one, if you use some libraries, or if you use the built-in versions of Unity, there's some immutable data structures. There's mainly the immutable list, and I couldn't find immutable dictionary, at least not on board. I think it's in .NET somewhere defined, but it's not part of Unity. You could have some external libraries, but the way they were used, I also didn't really like that. So I decided to do our own version of immutable state. And so we have model classes, and that would be one. That's the way we have our model classes defined. So each model has a state where you define your actual data types, right? They are publicly readable and only updatable, writable from internal from the class, basically. Every model has a current state, and you can retrieve that by calling model snapshot. You will get the current state whenever you want, without having to subscribe anything. And there is a behavior subject. I don't know if everybody is aware of behavior subjects. A subject usually is an observable object where you can push updates, and everybody who subscribes to it will get the changes. The behavior subject is a version of a subject which also pushes right away when you subscribe the initial state, which is a very handy feature. And yeah, that is just because you never should expose a subject to the public, because then somebody from outside could push something bad. So you convert it on the fly to an observable. And that would be one example for how to change a value. So if I just want to add something to that values list, I create a state mutation. I will come to that later, what it is. The create state mutation mutates the current state and calls a function that receives the state. And then on that state, you can modify the values. You can, in this case, because it's a container, create a new list, pass in all the values from the previous list, and just add to this new container, add the new value. So again, somebody who has the previous version of the state will have a previous reference to the value list, and will not be affected of what I'm doing here, but they will receive the new update with the next subscription update. Create state mutation is that part that actually mutates the state. You have to provide some way of cloning a current state. Member-wise clone is the easiest one. That's what we do. And then on this new version of the state, you call the mutator, which modifies the state. And then that's all. You just tell a subject, here's a new version of your state. And how do you use it? There's the pattern that we always use when we update when we subscribe to any model. We get the observable from a model. We select whatever we want from that view. We call distinct until change, so we only react to changes. Very handy in this case because we updated the actual container, meaning that's a new reference. So in this case, because the default implementation of distinct until changes just checks the reference pointer and not it doesn't do a deep compare of the actual lists. But because we created a new version of the list for all the values have changed, means a reference check is perfectly fine in 99% of the cases. Then we subscribe to the values. And that is something Unity specific because you can bind a subscription to an object, to a game object. And in case the game object is destroyed, the subscription is canceled. You don't have to do anything else about that. That's basically it. That's the way that we react to messages and update our model. So all the views will have instances of the game model in our case, because it's a very simple POC. There's only one or actually two models that we have that are relevant. And react and update the views based on that. I will show you afterwards in the demo. The benefit of having a central store for all the models is that we can also show in real time the content of the models while we're actually in the editor. And you can, in this view that we have, change in a very deep hierarchy. You can modify the data and you will immediately see the change reacted in the affected in the view. Also very nice. And I always liked it's obviously taken from, I think, the Redux library, which was a very nice Java library, which I always envied that you guys could have that, whoever is writing in JavaScript, and you can modify your data on the fly. That was very nice. So I tried to do a similar thing here. And I think you will like it if you're into Unity. So overview of the technology we use. Yeah, currently we're on, for this POC, we're on 22.3. Our SignalR implementation is from best HTTP. In general, we can recommend very nice request library. Is a paid library, 24 euros in the asset store. UniRX is the reactive stream implementation for Unity, which adds things like, this add to this that you've seen before. You can bind to game objects. The local message bus we have is a very small M-bus implementation, and we're using Senject as dependency injection, which I think is nowadays quite standard for Unity. I think most people who use dependency injection actually use Senject. That's it. Do we want to have any questions joined later, or does anybody have questions regarding the front end? What?
If there's any specific question.
Then you can continue with the backend details.
All right. Can you hear me well? All right. So for detailed question about backend and Unity, as we are two groups that might know nothing about the other technology, I think the best will be that we meet at the end with me and Peter. We will stay here a little bit longer, and then you guys can ask us detailed question about Unity or .NET or Cassandra or DataStax. Actually, we have Kai from DataStax. He can answer also detailed information about DataStax and Cassandra. And yeah, so backend. First, I will start with the technologies that we used. So obviously .NET, but why? So of course the team has experience with it, so I will not use anything else. Like most of the times you just go with what the team is expert with. You don't want to like try out too much outside of your like tree area. It's reliable and secure. It's high performance. We're using it for many years, so we know that this is the case. And it's a very good fit to be running containers since the last years with ASP.NET Core, .NET Core. It can also right now use low resource footprint in case you use IoT, so you can optimize it a lot. And maybe one benefit, for some it's not a benefit, it's actively developed by Microsoft. It's not going to die in 1 week or 2. It's going to be developed at least 2028. I can bet on that. So you can go with this technology. Recently there are many technologies that just go up and down, and then you're like out of support, and then you still have to update your game. It's not easy. SignalR, we're using it in production since 2018. We had absolutely no issues with it. The only issue we had at some point in production was we ran out of TCP ports, because when you have many players on very few nodes, instance of your backend, you can actually run on out of TCP ports on Windows servers. And we actually had that in production. It took us quite a bit to figure out, but the solution to that is just to use more servers. There's no way to go around it too much. But it's very fast. It can handle much load, as I said. And it's also supported for a web browser. So this fulfills one of our most important requirements. Then DataStax Astra. So this is our managed Cassandra database. We also host our own Cassandra database for our local development. This is also fine. But on production, I would not like to go into multi-node, multi-master, coordinator, all of the stuff that DataStax does for us, because it's a managed service. And we're using it since last year in production with Bloomberg Casino. We're very happy with it. As I said, it's multi-master, so it can scale. You don't have like a master replicas or any other technology where you have a bottleneck. You don't have bottlenecks. Has very fast and scalable writes. And it has a serverless pricing option, which is very good for starting with low scale, and then it can scale up. Also, this is something that you can discuss with Kai to how this would scale when you have higher load. All right, so Pulsar, this is used in the background by Astra CDC. You don't really have to manage it. It's just in the background, you see some configuration of it that is automatically implemented. But as a client, because we are listening to the messages that are being written to Pulsar, we need to have a Pulsar client. This is the first time that we tried it out. This was one of the testing parts. We wanted to check it out. So unfortunately, what I found out that it has partial .NET support. In particular, Pulsar uses other types for the serialization, deserialization. This is something that people that have more familiar with Kafka know this well, or in Java. In .NET, this is not really well supported by the main library that is there, which is called .pulsar. So I had to do some workaround, some hacky things in order to properly deserialize the information, but it worked. We have it running and it's all well. The performance until now, we didn't put like an actual stress test on it or a load test, but the performance was good enough for our result here for Naval Battle. But of course, we need to gather more experience about it to see if this can actually go in production. Then the last technology in the backend, and actually I will explain why this is in the backend, because what we like to do in the backend is to have a test client, a web test client, because I like to spin up my .NET backend locally, and I want to connect it very quickly with something, with some client. And with Unity, it's a bit heavy. I'm not very expert with Unity. So what I used is Vue, Pinia, Tailwind, Vite, which is like a small JavaScript ecosystem. This is my go-to ecosystem for quick prototyping. I use it for many years. It's very fast, very easy to use. We actually use it in production on our web platform since 2018. So I am in particular very familiar with it. It's simple, but it's powerful. Now, so backend logic. Here, I will start with the data flow. So offer an example of one of the actions that the client do. So in this case, it's hitting an enemy position. The player connects to SignalR, as we said, and he sends the hit action to the backend that contains the battle ID and the coordinate that you want to destroy. the .NET SignalR has a state in memory, as I told you before, and guards against the invalid moves. What can be invalid moves? Very obvious, like you try to hit a coordinate that doesn't exist. Weird case if there is a bug in the front end, or you try to do something but it's not your turn, or this kind of guards. But it's only guarding, and everything is based in memory at this point. If the action can pass, so it's a valid action, it will be stored on DataStax as a Cassandra database. At this point, the state in the backend didn't update, just let pass through the action. So DataStax will move this information to DataStax Asta CDC, which will move to Pulsar, which will be listened by the backend. And only at this point, I'm calculating the new state. So because by doing this, no matter how many backend instances I have, all of them will read these messages. You can configure how you want to read these messages from Pulsar. In my case, I want to sort of like broadcast to all of the active instances. And I can say, okay, I have the previous state in memory. I have the new information, the new action, and I apply the action and I calculate the new state and the result that the front end needs. I don't send the whole state. I only send the delta, basically, only the information that has changed. For example, if you hit or you had a miss and some metadata, for example, if you completely destroy the ship that is needed in the front end. The other important part is what happens if something breaks or goes wrong in the backend. So we need to have a system in place to sync or restore the battle state. So something that can go wrong is the client sends you some information to the backend, an action, for example, again, hit position, and also passes as a parameter, in addition to the coordinates, pass the state that had received previously. So the client stores the previous backend state information, like a timestamp or something that the backend sent to the front end in the previous result. If the backend notices that this state is invalid, so the front end has a newer state than the state that the backend has, we trigger some restore state mechanisms. So we read from Cassandra all of the rows where the state is greater than the one that I have in memory. So hopefully this will bring me to the same level as the client has. And at that point, I can proceed with my action. So again, when the action is inserted, it goes to Pulsar, and Pulsar sends the data back to our backends. And hopefully at this point, all of the backends have a valid state. And the state, the timestamp is sent back to the front end so that the front end can send it back with the next action. We're done. So this is that's why I said in the backend I didn't want to go too much into detail. But if you have specific questions about how these things happen, you can ask me at the end. Right now we have the demo time. So me and Peter will actually spin up the backend and the front end, and we're gonna start playing. Yeah, and let's see who wins. So give me a second. You don't see my screen. I have to stop the screen sharing. Yeah. All right, so okay, you don't have to see the backend stuff. I will just run it locally. It's just like I'm using Rider and just hitting play. And it started. So you, Peter, can connect. By the way, I'm using for Peter to connect to me. We just use NGRock. I don't know if everyone is familiar with NGRock. It's a tool. It's an open source free tool that you can use. Now I think it also has a paid version, but it opens a tunnel to your local machine so that anyone can connect without setting up firewall rules or port forwarding or anything. So right now, Peter will have a little bit of extra latency because we're going to do a bigger round trip than if we were in the same network, but it's fine. And I will show you the test client. So are you connected? So let's see if it works. And we're connected. So Peter has his Unity client. He will show it to you soon. This is my test client done with Vue.js. So here I try to reproduce basically what happens in the Unity game. So I have two boards. The one on the bottom is my board with my available ships. The one above is Peter's board. And he already placed two ships, now three. You can see enemy ships, three are unknown. Depending on the game rules, sometimes you see the ships of the enemy. In this case, we just put unknown, and we allow the players to only know the ship only when you destroy it. And some debug information with the latencies that we're having. So right now we're not hitting our 150 milliseconds, also because of the tunnel that we're setting with NGRock. So Peter already placed his ships. I'm gonna place mine. Yes, I didn't spend too much time on the making it fancy, so I hope you like it anyways. So you can rotate the ship. And you mark yourself as ready. Okay, the latencies are much better. Probably the join battle, just because I started the backend instance, it took a little bit to resynchronize, but all right. Good. So the information that is relevant for me now is that it's Peter's turn. So Peter, please try to guess. Are you looking?
Of course, I'm looking.
Hopefully. Don't cheat, please. So, okay, so we see that he hit the location, but he didn't hit anything. So I'm gonna try to hit also nothing. Also, you see also here we have a view with Piña as a reactive state. It's the same stuff that is happening in Unity, but in JavaScript. So you see in real time the results of your queries. Damn it.
Oh, that means I was close. All right, all right, all right.
Okay, he's not cheating. Damn it. Of course. Some rules of the game are that when you hit a location, it continues to be your turn. We didn't make it this way. We could. We just made it that every time the turn switches between players. Of course. And you can see the state here is sunk.
So do we want to switch the client, or do we want to start a new game for showing the new client?
No, it's fine. We can switch now. So okay, you saw the test client. That's it. It's very comfy for prototyping and debugging my backend APIs very quickly. And now you will see the nice stuff that the players will get.
Again, it's code art. Don't sell it too big.
The very fancy Unity.
Yeah. So wait.
I still have to keep playing with you.
So can you make some space here? Come on.
Sorry.
Yeah.
I will go here so I don't see his battle. I mean, I can see it here, but I will not look.
Oh yeah. Yeah. So here you can also see our the main view, but you can also see the where's my mouse pointer? Oh, here. The real-time update of a current model, right? So you can, first of all, you can see all the messages we receive here, that we send. Everything is here. So when I click somewhere, that's my interpretation of a shot here, right? You have to applaud now because it is super awesome. So you see all the messages that are received and sent. That's quite handy, and also that's the real-time view of the data of the internal data model. Then I could let's say, I don't know, change where it is here, saying it's a hit position or not, or whatever. So that's quite handy. And the very cool part about that is something that actually Dawn did. We can also connect it to an actual device via cable and see the real-time internal data model in the editor of a connected device. That's very nice for debugging. So let's just continue playing. Hey, come on, man.
I still have no ships. Crazy.
Oh yeah, I should have known. Come on.
That was close.
How did you manage to
You can rotate.
not hit a single thing?
At that, I don't know. I was not cheating. Eh?
What are you?
Finally.
Yeah. Okay.
Sometimes you're not the best at the games you build. That's yeah, this will take forever.
Let's just say a 1, huh?
Okay, so you don't see it on my side, but now I know that I hit a cruiser from his side and it's completely sunk. Did you put it in the? No, I put it in the corner.
Come on. No, I'm making it extra hard.
All right.
Yeah. Let's just say
Well-
1, 2 out of 3. That's fine.
Let's do it this way. Let's make it a little bit faster.
Come on, here? Really? It's basically here.
No,
No,
it's here.
other way around.
Ivan.
Yeah, because we have it vertically mirrored, but not horizontally. Okay.
Oh, now I'm winning. Don't tell me. So it's here. Here.
Oh, it's that.
Ah, it's sorry. Yeah, are you doing it on purpose?
Oh, it's the first one. Damn it. No. Yes. Okay.
All right.
So that's it.
I need this one. Good. I hope you liked the game. We will not publish it, unfortunately. It's very nice. The
But it's
graphics are
company
amazing,
policy.
but
Too less of a gamble.
no, I mean I think it's just we have actually. Do we have a point in the slides where we explain what is missing to actually go on production? I think we wanted to
It's like
say this,
everything.
but it's
What
a
do you mean?
lot.
What is missing
I
for
think
production?
we would run out of time. Yeah. So where's my mouse? So does it still work? Nice. So we are almost at the end. We have a little bit of questions answered by us, and then we can go with your questions. If you think they are relevant for everybody, if not, if very specific internals of .NET or Unity, please come here to me and Peter, and we will discuss with you. So the first question comes actually from my team. So they asked me, why didn't you come up with Redis solution? Because Redis can manage distributed state, or you can synchronize the state with PubSub very easily. There's no real reason to not using Redis. I think it's also a good fit. It's just that in this case, I wanted to test like the minimum amount of tools to be used to achieve this result. So in this case, DataStax Asta and the CDC and the Pulsar part was already just there, and I would not have to use anything else. In this case, if I would have to set up Redis, I would have an additional tool and additional managing, and I would have achieved the same thing as with DataStax completely. So I was already happy with it. Orleans or Akka. So this game fits very well as a candidate for using Orleans, and you could use the battle as a silo and the battle as a grain. I'm not really familiar with Orleans. I didn't want to learn the whole Orleans just to make this game. I wanted to test a little bit of things, because otherwise, when you try to go too big, you end up like giving up or having some prototype that is like completely broken because you tried too many things at the same time. So I think Orleans or Akka would be a good fit for this kind of game. I just didn't have time for the moment to use it. Why DataStax and Asta with Cassandra and not Postgres with Postgres CDC? This is also a good solution. We're using it actually in production. It's fine. It's just, I feel with Pulsar, you have a little bit more ways to actually consume the messages in case you want to do some fine tune, for example, like acknowledging or the single messages or like reading in broadcast like I'm doing. So yeah, that's one reason. And Postgres doesn't scale that much as Cassandra. It does scale, of course, and there are like multi instance of Postgres. I think it's called Citus or something like this. You could scale globally with Postgres, but probably Cassandra does a better job at this. How to handle cheating. So I mentioned before, players send actions to the backend. Right now, there is nothing that could prevent the same player to send the action 100 times to the backend, and that action in that moment will be valid because the backend has the state in memory and there is no synchronization with the database. So in this case, you can cheat. The players can send multiple commands at the same time. You can handle it maybe with a lock. You can handle it with a distributed lock. You can use some tools that will allow you that the same player of the same battle goes to the same SignalR server, so they hit the same instance all the time. But there are many things to be prevented in order to handle cheating for a production-ready game. And what is OpenCost? Very quickly, it's an open source tool that you can deploy on your Kubernetes cluster. I think also not Kubernetes cluster, and you can configure it to read the information from your Azure, AWS, or GCP, and to display all of your costs sort of in real time, and to have like fine-grained information about specific services, how much they are costing, and this is really interesting. And that's all. Thank you very much. Do you have any questions? Good, then.
Yes, we do have.
Yes.
In the case that the client hangs, well, at some point between now or infinity, and the callback for the end of the game may trigger some event, do you build some fail-safes, like recalling the server to try again or receive the most recent model? And how does this look like?
This is for you, Peter.
Well, for this demo, that's mostly an implementation of the happy path, to be honest. So the network connections in this world that I implemented the POC are always there, never fail. And that's really just because of not having too unlimited time. So those kind of things are not really handled well. In that POC, what we usually do is, for Bloom Lucene, of course, if network connection is lost, for instance, and then we reconnect, on the reconnection event, we would refetch certain states of the backend again, so that we're up to date. That I didn't do for the POC.
And one second question that you may have answered partially already about you may have answered it during the cheating part, about backend restoration. Which state do you trust, and what is the reasoning behind it? So in other words, how to pinpoint the correct state?
Right. So I think yes, I partially answered this with the cheating part, but the main information is the timestamp. So this is something that the backend sends to the front end, then the front end replies to in the next request. This could be enhanced to use some sort of cryptographic data that only the backend can read, sort of like similar to how JWT tokens exist. And the backend can know that this is the valid state that he generated in previously, like similar to the anti-forgery token that you have in .NET.
If sorry, if there are no further questions from the audience, there's one.
My question is, isn't it this implementation more like command sourcing than event sourcing?
CQRS, you mean?
No, because I thought you are saving the actions in the Cassandra,
Right.
and broadcasting them. So you're not saving events in the.
I think that the name was a bit misleading because like most people know event sourcing, that's why I used it, but I'm not saving the results, so not the events. I'm saving the commands that are going to be replayed afterwards. It's just for the sake of simplicity of the replays. It's much easier to replay to add the action information to rebuild the state than taking snapshots of the state with like actual event sourcing. But yeah, it was written event sourcing, but it's not. It's more command sourcing. Yes.
And another question is about event broadcasting. Couldn't you have just subscribed to on the servers? If you have like 10,000 servers and lots of games or something like that, every server has to process every event.
Right. So, well, for this proof of concept, I didn't want to solve this problem, but in real life, you would you have two options. So yes, either you consume all of the messages on all of the nodes and you discard the messages that you're not interested into. So this basically is like the messaging system is stupid and the logic is handled in the backend. Or you use partitioning. So you maybe use the battle ID as a partition key, and then you only consume the messages that belong to that partition. It depends really on the system that you're using. I think this would be possible with Pulsar. So this could be a possible solution that I can think of now.
Thank you.
You're welcome.
I would. I have a question. You mentioned that the game is not yet in production, but or not in production. I don't know about the plans, but I guess it was one of the goals for the proof of concept was scalability. So I guess you had some way. How did you test? Did you already test the scalability, and how did you test it?
So to be honest, we didn't have time. Actually, we finished developing this POC like very late last week. So the scalability has to be tested. Like I said, we just tested like with 2 instances just to make sure that the code runs with 2 backends. The problem we have right now is that our matchmaking is in memory, and if 2 players are connected to 2 SignalR servers, they don't communicate between each other, and they will not matchmake between each other unless they hit the same server. But at that point, we're not testing properly the load balancing and so on. So in order to achieve this, first we have to implement some sort of like distributed matchmaking, maybe using Redis at that point, or other libraries or other solutions. Maybe Cassandra can also be used, and then you can start doing the load test and the stress test.
So you're still planning to do that, and you maybe give us an update in one of the next Unity meetups.
Absolutely. So I showed it this demo and this game, the source code to the backend team, and we liked it, and we plan to use it as a sort of playground for testing out ideas. So because it's very easy to modify a very simple game like this without having to deal with like real players and so on. And there we can experiment and we can do these things. But of course, like the first thing that we would have to do is to fix the concurrency and distribution.
Thank you.
In the chat, Hannes is writing, thank you for the presentation. Is the code publicly available?
So, the code is very ugly. Sorry for that. I can, if someone sends the email, I will. So first of all, I'm not sure if he's talking about the backend code or the Unity code, but I guess it valid also for you, Peter. If someone asks for the code, we can provide it because it doesn't contain any business logic of any platforms that we develop. So yeah, just put your email and I will email you next week, maybe when I clean it up a little bit. I still have some comments of things that are not existing. So yes.
Any other question? Awkward silence.
Elevator music. All right, then thank you everyone, and I hope you have something to take home. And yeah, you can also write me and Peter via email somehow, or come here, and then we will get your email and we can talk later, also exchange messages. Thank you.
One moment. Wait. We are not done yet. One moment, please. That was the wrong button. Sorry. So, can you stream? Good. Yeah. Thank you, you two, and Daniel, for giving the talk. Everybody, every speaker at the .NET events gets some small present. The first one, sadly, I only have one, so you get one. I have to produce them. So first is a custom coaster with our logo. So one, the other two will get one, and what they also get. So what you all can get are some of our stickers. They're there at the table. A collection of the last events, our logo in different colors, and the speakers get a complete set. Yeah. So there are also some other .NET related stickers there. So yeah, thanks again to our sponsors, to every Rubicon and JetBrains, and Greentube here for the location. We still have to do the raffle. So if you want to, oh no. So problem. So let's see how many draws are still, entries are still there after refreshing. Oh. The one time I started on time, then it doesn't work. So nine left. So let's see who is the lucky winner. Why we are ourselves in there? So Chris, if Chris is here in the audience, please come after from the chat. Okay, then please, Chris, please contact us at the email address. It's team@.netdevs.at. And yeah, the last thing, we always want to improve these events, and we have a small, big QR code, small feedback form. If you could fill it out quickly, it would help us improve these events. And that we are done, and I think the drinks and food are outside in the back. Outside. So have a nice evening. See you the next time. Bye.